Good morning, all. Our topic today we are going to cover through virtual classes. Virtual class is game playing. In that, as we already we covered this topic, but as some students requested me to discuss again, is to take some example related to Minimax and alpha beta pruning. So today I will try to discuss with you this Minimax with alpha beta pruning. I hope you will understand this one and it will help you in exams later. So really what we was doing in this state space search, that type of searching problem. So one of that whatever we was getting here, that is is this game playing. So in this game playing, really what it is there, this is a simple we are having here two different players are there, and that players means to play a game, how they will move it means once if one person, one particular player if taking one action, of course other player it will take opposite decision to that, means both are going for win, means if you are choosing a choosing particular that move that action or possible that move to win the game, then opponent will try to uh, defeat you, try so that means win and lose something, that type of it will go on. So the minimax means you are going to maximize your possibility to win, whereas the other one, he will always try to minimize your possibility to win. So that is only minimax algorithm. So we will discuss that one in this our today's virtual lecture. The minimax algorithm is a way of finding an optimal move in a two players game. Yes, it is that we will try to get a optimal move so that we can win that particular game. So here one point I want to discuss with you, that how we will hi Vishwanathan, we will continue with that. So what I told you means this alpha beta pruning, we to make difference between minimax and alpha beta pruning. So minimax what we was doing now, that simply we will visit every node. If in a tree mode we are taking our problem, then from root we are having different means child of that one and child of again and again for that one, and finally we will go to the leaves. So that one. So in minimax we are going to visit every node, but when we are going for alpha beta pruning, then we will go to some selective nodes only. Means how we will select that one, means we are going to avoid some nodes, but how we will avoid that one, that is here point only. So that what is an alpha beta pruning is a way to finding the optimal minimax solution while avoiding searching subtrees of moves which won't be selected. Means of course we will not select some moves. So in the search tree for the two players game, there is two kind of nodes. Nodes represents that our move, means we are trying to maximize our chances to win. So that is our move, and opponent's move. Means opponent's move means really opponent's move means that will be he will always minimize our chances to win that game. So that is only here means in this minimax only. So so minimax algorithm is a way of finding an optimal move, that just that we told now, that case only. So what will be there in max and min? So what is that max? As already I told you that nodes representing our moves are generally drawn. Yeah, that how we will represent that max and min. So max generally in this tree form, how we will present, either that may be a square or it will be a triangle, means here that is a triangle and with that single peak that will be upwards only. So that will be there. So that is also called as a max, or we can represent by symbols. But here really what is the our main goal for max is to maximize our chances, maximize the value of subtree rooted at the node, or simply in our words we can tell that our chances to win the game, that one. So for this, if you are on the root or you are on the top root and your children means your that other nodes means it's whatever we are getting. So in this, how we will select the maximum. So whatever what that root is having child, and for that child we will check that what are the values there. From children of its we will take the maximum of that one, that value will be taken there. And this max is also called as alpha. Alpha means now I am connecting with alpha beta, so max means that is also called as alpha. So whatever the maximum value for a root its children is having, we will find out the maximum value and that will be our alpha. And that same when we are going for min, that time also we will take that same only. So here that last line you can see the goal of min node is to minimize the value of subtree rooted at the node. So minimize, we will try to minimize that values. And to do this, a min node choose the child with the least smallest value. Yeah, that one only. That again, that if same conditions it's coming, here we are having root node and we are having other means it's a children node. From children node we will compare and we will find out the minimum value of that one, and that value will be given to the root, but that value will be given to beta. Beta means that is for min. So here what it is there in this minimax, that symbol means presentation we will present by that square or that tree with upper means upwards type, that type of, that is max. Min means it will be a circle, and otherwise a tree that is downwards pointing, that type of that will be our this particular we was having here for min. So next, whatever that how we are going to present this one, alpha beta pruning gets its why we are giving this name alpha and beta. So or in this alpha and beta, that just before this slide I told that alpha means for max and beta is for min. But here you see, so how that alpha is the maximum lower bound of possible solutions, whereas beta is the minimum upper bound. What it's meaning, the upper bound and lower bound for that one? So initially these values what we are taking here, so in that you see that what I told you, that this min and max. So this alpha and beta in this value for alpha means whatever that value of child it's having, from that values we will take and we will give to that alpha. But when initially we are starting with, that time we are not having child and we are starting from the node, that starting from the root, that time what type of values we will give to alpha and beta? So alpha, because this is maximum lower bound, so maximum lower bound means alpha, but maximum lowest bound, what is the possible lowest value we can give to alpha? That is minus infinite. Please note minus infinite, whereas for beta we will give for plus infinite. So that is only the difference whatever we are means we can make difference between that, and on the basis of these two bounds we will give that as alpha beta pruning. So here you can see alpha is less than or equal to n, that particular value we are having, less than or equal to beta. N means for particular node whatever that value we are having. So here this for alpha, this we are getting maximum lower bound, and beta we are getting for that. Later means the same we can understand by a number line also, and as we will proceed we will go for that values which will be here we can get that okay these values are means here how it is making changes in that one, how we will make changes in these values for each node, that may be min or max, or for that alpha or beta values, how that will be changed. So okay, this is today that a problem we will discuss. We will try to understand this one simply. What in this one is here we are having one, two, this one you can see this one as here we will take these values as this is my initial that node we was having I think it's connected. I'm connecting it again. Yeah, okay. Is it's audio? Is it going on? Yeah, welcome, Satvik. Is it video is visible there or not? Yeah, it's okay. It's why it's not coming. Satvik and Sai, once please. I'm disconnect. Okay, I'll continue this one, but this video, is it coming? Okay, fine. What it is coming there that in this why it's not coming? Once I will stop this one and I will restart that. Why it's not coming there? Okay, Satvik and Sai, this is I think it is not visible for you, that particular slide. What is there? Okay, so this is on the root. Whatever we are getting this node, and whatever the children, it's we was getting, because that without that, how it is possible, Satvik? How it will not be visible to you. Once I will recall, I will.
No, the slide is visible.
It's visible.
Yes, sir.
So, but it's coming waiting for next. Okay, fine. I will continue
No,
then.
slides are
Okay, then what is there? This we will try to understand this alpha beta pruning, and this one Minimax as I continued. For this example, you see that this is the root node, and these are Minimax, and this root node. This is because that symbol, particularly square symbol, we are using. That is for max, and this one circle is there. That is for min. And like that we will go for that according to the depth. So we will go according to depth first search here. So this is my first root node. So as I told you that we will go for alpha and beta pruning. So we will start like this one. Now you see, this is my root node. Whatever that in right hand side, I have taken this main that our problem, and left
Yes,
hand
sir.
side my solution. One by one, we will go for that solution and how we will go to the depth, means according to the depth of search. So in this one, you see that alpha, as I told you, that alpha and beta values, alpha will be the maximum lower bound, means maximum values we will take, but as initially that values we are not having, so we are taking minus infinite, means we are taking the worst case of this one. Like that for beta, that is for mini. So min, so for min we are taking the worst case of this one, means worst case of this one we are taking means that maximum, that whatever that infinite plus positive infinite we are taking. So this is my initial route. So one by one, by this way we will go to next only, because still it is not the last means depth. So we will go to next min, and there we will take again these values of alpha and beta. So here also it's still it is remaining like that only for alpha and beta. Alpha means max, beta means min. This alpha we are taking is that still we are remaining with that value minus infinite, and beta means plus infinite. And we will carry on like this only, because you can see right hand side the problem given to you. We will go, we are trying to go to the last node, or we are going to the leaf, right Satvik? So that one here you can see means this next we are going, and after that we are
Yes, sir.
reaching here at this node, means this node. So first one was max min. So this min is there. Now this is my fourth depth, right? So for this fourth node, we are having here
Yes, yes.
some numbers for that. Some, because this is leaf we got, and these numbers three is there, right? So now in this one, now this
Yes, sir.
value is there, and for this for this leaf, parent is min. So parent is min here. So for this min, see here, min is there, means we will update the value of beta. Beta earlier we are having infinite, that is plus infinite, right? Plus infinite. Because min is there, because as I told you, beta that plus infinite is the worst case. So we will update this one, we will change this one with 3, because 3 is better than 1, because plus infinite is the worst case. So in this one we will take this 3 here in place of this infinite. So you can see that now we will replace this beta by 3. So this is my updated value for that one, because that according to that we are changing for that. So now as I told you that number line, if number line we will see that earlier values, you can see the first diagram, in that alpha and beta it's given now. So that is I told that we are for alpha we are taking the maximum lower bound, and for beta we took that minimum upper bound. So alpha and beta. So after that
Yes,
beta we have given the value 3. So our worst case, that plus infinite is not more. Now beta value is 3. So this is my current situation that time. So now you see here means this particular earlier we was taking the, now for this same this node min node, we are having one more child, or we are having one more leaf of that leaf connected to this one. So that is 17. So for this how we will go? So if, okay, by the way, means beta already we are having 3, and this is for min node, this alpha and beta value for min. So this 17 is there. So this 17, what we will do here, this 17 we will try to make changes in this beta. But you see that 17 is more than 3, and for beta, that is the, we will take minimum upper bound. So so minimum upper bound, that one, so that was there already. It means in this one 3 and 17, in this way we will check them, 3 is better than 17, because we are going for minimizing. So there will be no change in this one, because we will not connect this 17, but we visited. One thing I want to tell, that we visited Still that situation didn't come that we have not visited particular node or we are ignoring that one. So by this way, now you see this is there, and now whatever the values, because beta value is not changed. Now we will check the what is the parent of this min, that because whatever the three values, because as I told you 3 and 17 was there, 17 will not be changed, and this three value will be given to this particular whatever we are having here, this beta value, for that will be my value, current value given to this min node. So with this min node, with this alpha and beta values, we are going to upper that parent, means it's parent of this child. So for with that we will carry that means values of this beta, but that value will be replaced to alpha. Why it will be replaced to alpha? Because this is max here. In max means we will try to maximize the value. We will try to maximize the value, so that will be 3, right? So that will we will be 3, and alpha again it will be plus infinite. That is we told now that minimum upper bound, that value. So now we will see for this uh, particular that max, what is there any child available? So yes, it is available. Then we will see that okay, this is again a min. So we will go for that. With min, whatever the values we were having beta and alpha, that we are bringing here. And after that we will check that this min is having any child or not. So yes, that is having two child here, means that earlier that I've shown you in this one, the right hand side you can see two child is there, 2 and 12. So okay, we will go for this first one, that's 2. So this 2, and this earlier that node is, that is min. So here 2 is there, means beta is for min. So this 2 we will replace that beta, that infinite, and earlier we are having, so new value will be 2 here. So that will be our updated value or changed value here. So this 2 will be there, and now again we will check that this particular min node is having any other children or not, any other leaf is connected to this one or not. If yes, then we will check yes, that beta is value, new value was 2 given, and after that we will check that any other leaf is connected to this one or not. So that time you see, before that going for, yes, it was there, the 1201 number is there, but before that we will check this min node with the that other available max node for this one. That is earlier that we was having the max, from where this means parent of this min. So that max already it's having value alpha is equal to 3. So here in this my min node, there also we was having the value, this one. We was having the value alpha is equal to, hi Gaurav and Prem. So this is alpha is equal to 3 and beta is equal to 2.
Hello, sir.
So that means alpha is equal to 3 and beta is equal to 2. So now in this parent you see that 3 value already alpha is having. So really this is that here we are trying to understand that how we will cut that particular number, means we are not going to visit particular number, that 12. It's given here na, this in this picture, this is 12 was there. The right hand side that image is there na, for that fourth layer, you can see one number 12. So this will not be visited, but why it will not be visited, that we are going to discuss. So alpha is equal to 3 for this min, and beta is equal to 2. So now you see that upper bound, that max is having 3 here. So that 3 means we cannot have any value more than that, no, sorry, lower than that. We cannot have any value lower than that. We will have all values 3 or more than that. Right? We will have values 3 or more than that. So in this one, this min means if any number is there, we are having the beta value 2 here. If any other value we will take from its leaf, that value should be lower than 2, then only we can change this value of beta. Then only we can change this value of beta. Otherwise, we cannot change. So what I want to tell, that even we are going, means if we are changing the value of beta, that all will go lower than 2. So that 2 will not be replaced for its parent, that whatever we was having na, that parent node for this one, that is our max. In that we are having alpha is equal to 2 and beta is equal to that infinite. So it means we need not to visit to 12. So you can see that condition here. So that because already we are having 3 here, and other values whatever we are getting, that is getting, we are getting less than that one only. Always we are getting less than that. So you can see here the symbol it's given, that because of this reason we are not going to this number 12, right? That will be there. So after that, again, now whatever that value 2 will be replaced for this node, because we have not gone to any other node, and so this 2 is my final value for this particularly min. And for max, that we will see that whatever the 3 value is there, the maximum, that will be its value at that max node. Now I'm going to that upper that node, that is a min. That is a min here. So this is here, you see that min. So when I'm going for min, again you see that min I told maximum, lower value. So sorry, maximum upper bound, maximum here upper, so that one. So in this one you see that alpha is equal to 3 we are having, because plus infinite already I told, no, that was there. So we are having this 3 value, so that will be replaced by this one only. So again, that same steps will be there for this particular min node. We will see that how many children are available there. So this is min. So we will check that what max is available there. Gaurav, are you understanding? Prem, Satvik?
Yes, sir.
Yes, sir. Yes,
Yes,
sir.
sir. Yes, sir.
Yes, sir.
So this is, now you see this is min here and this is max. So when we are going for max, that time you see that same values we are taking. Again, means this one what we are doing, we are going to the depth. So this is max. Again, next we will try that what will be next node. So again we will see that one more min is there, and after that we will go for that particularly we are going to that particular number for this last depth we are having. This is 15. You can see right hand side that that example means that tree, the main tree. In that 15 is there, only single number is connected with this min. So now this 15 we are having. That time you see we are having beta is equal to, that time this min is having beta is equal to 3 and alpha is equal to minus infinite.
Infinity.
So that time now see 15 and beta is equal to 3 we are having. Beta means minimizing that. We are going to minimize that. 15 is not lower than 3. So already we visited this one. We are not ignoring this one. We are not avoiding. We visited this one. But this value will not be replaced by beta. But this value will be given to this min node. So that you can check here. That see that beta is not updated, but this value is given to this min node. But when we are going to the upper that parent, means upper, that is the max. So that time beta is there and alpha we are already having that minus infinite. And again we will check that for this max any other child is there or not. Yes, it is there. So that means child is there, but for that again before going to that, it is better for us to check the parent of this max, because with this whatever that values updated, earlier values for min we was having 15 na, that we have taken here that 15, and this value means here alpha is for this max we are having this, for this particular max we are having 15, alpha is equal to 15 and beta is equal to 3. So now these are the values. For these values, for this max, this is here. This is here parent of this one. So for this parent, here parent is min. So here we are trying to minimize the value. We are trying to minimize the value from this alpha. But alpha is already having higher value and we are having lower value here. So even if we are going down, we are going for any other parent, any other child available to this max, that is not useful for us, because that values, because this is maximizing. Either value will be 15 or more than that. But when we will go for our parent, that time the value required is 3 only. So after this, whatever that values will be there, that all will be ignored by us. You can check it here. You can see that symbol is there, double line is given. So we are not going for means other children of this max 15. Yes, are you, Prem, this is there, are you following? Okay,
Yes,
that's
sir. Yes,
fine.
sir.
That will be there. And after that, see this all condition with that, whatever that values of beta that is equal to 3 we are having, na, that the 3 value will be given to this particularly this min, and that value will go to its upper also. That is a max, so that value will be given to alpha. So like that, now we will see again, we will go for this, whatever the children available for this. So for this, whatever the children is, it's a min. Again, we will check that this is a max here, and again this is a min here, and finally whatever we are having for this min, we are having two values, that 2 and 5. So the 2 and 5, this is min here. So beta we are having infinite. So 2 is there. So we will try to minimize these values. So of course infinite plus infinite is more than 2. So this beta will be replaced by 2. So this is here, you can see the 2 is replaced, beta is replaced. And now we will check for other conditions. Means other children available for this or not, because alpha is equal to 3 we are having for this, particularly this min, and parent of this max, parent of this min is this max, where we are having the value of alpha, means alpha is equal to 3. So in this 3, you see, in this 3 means what its meaning is, here this is max, so here we will have value of alpha is equal to 3 or more than that. But here minimizing, already we are having value equal to alpha and 2. So even this is, even means if we are going for next line, this minimizer will not allow to take any value higher than that, because here whatever that changes will be there, changes in the beta only, because this is minimizing. So here the 2 and 3, so it is not change, but for me the value of alpha is required. So whatever that alpha means, here minimizing means if any value will come, that will be 2 or less than 2. So I will not go to that. So for this, you see that we will take this means 2, whatever the 2 we are having from that one only, but we will not visit to the children of this particular min. We will not visit to that number, because that is already we are having this 3 and 2 na? So from that is enough for us. If any other value we will visit to that one, that value will be may come 2 or less than 2. So because of that we are not visiting this one. Now you see, that is whatever that I've shown you now, that we are not going to visit this one. And after that we are going for next step. In that we will that our max, that alpha is equal to 3. Here we will check that uh, uh, any other node is available or not, any other its child is available or not. Yes, it is available as a min. For that also we will check that any other children is available for this. So you can see here that number is available, that as a as 3. So here you see this 3, this is our last that leaf, but this we will replace for this minimizer. Minimizer means alpha is having value, earlier we are having, this is alpha is equal to infinite, and 3 is better than that, because we are minimizing that one na? So here alpha that we will get as 3 here, and that will be replaced like this one. So in this way, you are you miss this way, Prem? Can you do this alpha beta pruning? The that one, Gaurav, Satvik. So this way means, are you able to do this steps?
क्या
Because that is required here.
Sir, his laptop is having some problem. Prem.
Oh, so that one, okay. That
Sir,
means
he's doing
these
this.
are the steps. I will upload this one for you, and you go through that,
Yes,
because
sir.
every steps will be given there. All I given nearly 40 slides is there. That way we can understand that which one is there. So you to understand that alpha and beta means minimizing and maximizing,
Hmm.
and that condition is one when we will cut that particular number. That is important for us.
Pruning.
Correct, Gaurav?
Yes, sir.
Gaurav, that
Yes, sir.
means main point is that this, if this type of problem is coming there, na, then means that number, which number we will cut, that we to cut the proper number.
Huh. Yes, sir.
So that is only a point here. Satvik, you are also online.
Yes, sir. Yes, sir.
Okay. So these steps will be there, and by that way you can go for that. So next means in this means whatever that remaining is there, again we will go to this its parent node, and whatever the values are updated
Hmm.
means changed for alpha and beta we will go, and by that way we will try to go to the last one also, that whatever that values we are having for that. So finally we will uh, means here that we will make the difference between minimax and alpha beta in this in such a way that minimax we are visiting every node, but in alpha beta we are avoiding some nodes, we have some selected nodes, but how we are selecting that one, how that particular node we will node visit, that is important for us. So for this alpha beta pruning, just you start from means alpha is equal to this that minus infinite, minus infinite, alpha means max,
Beta equals to infinite.
minus infinite means whatever that we are taking
Yes, sir.
here, worst condition of maximum means maximum value, worst
Hmm.
condition, because minus infinite with that, so later we can replace that one. For beta also it is like that
Yes,
only,
sir.
and that way we'll go. So this is only simple that remaining steps you can finish in that one. These steps we understood that how it is going on. So that type of problems is it will be. So any other, if you want to ask about syllabus and all, because now we are not taking classes, so that you can ask. Gaurav,
Uh,
Prem?
Sir, about GA, you uploaded the slides. GA,
This one,
genetic algorithm.
genetic algorithm, I uploaded, I think so. I not uploaded.
Sir, let me check.
Okay, if it is not there, then I will upload that. I hope all slides are uploaded. If it is
Yes.
not there, you
Okay,
check
sir.
particular where is genetic algorithm. It is written there only. It may be.
Ah, yes, sir, it's there. It's there.
Okay, that one only. Otherwise, anytime you can come to my cabin also. That you can ask, or you can call me also. That time you can if any particular portion is there in course or not. That type of you can discuss with me. Okay, okay, we will close now.
Yes,
Hello,
thank you, sir.
Gaurav. We may close
Yes,
now.
sir. Okay.
Okay. Okay, then.
Yes, sir, we can close. Yes, sir.
Okay, okay, then. Okay, all of us. Okay, Satvik. Okay, Prem. Okay, Gaurav.
Thank you, sir.
Thank you. Okay, bye.